Yeah, I'm adjusting. We're going live. It's 7:12. What's going on, guys? Tonight we're going to talk about turbos. And one of the ratings that guys use all the time is how much horsepower it makes per PSI. Guys talk about a lot, like, oh, my motor's making 25 horsepower per PSI or 30 horsepower per PSI. The question is that accurate measurement? And then if it is, the other question is, how do we improve that? How can we get our turbo to make more horsepower per PSI? Can we change the size of the turbo? Like, we go to a bigger turbo, is it going to make more boost per PSI, or more horsepower per PSI is going to make more boost? Obviously, the easy way to add power to any of these turbo motors, like this one, whoa, S480 Borg Warner, is to add boost. But how do you make sure that each pound of boost gives you the maximum amount of power? So we're going to talk about that tonight. Lots of cool turbo stuff going on, how to make that better. And we'll talk about things that stop some of that efficiency and things that you can change to improve that situation. The thing with turbos is a lot of guys are in the area where if they just add a turbo, you know what the old saying is, I need to have shirts made. Just add boost, and then good things will happen. Everything is better with boost. There's no doubt about that. So no matter what motor you have, for instance, right now I'm working on the Wrecking Yard Dodge 360 Magnum. If you just add boost to that, it will pick up a lot of power. And the nice thing about turbos is that if you want a little bit more power, you can add a little bit more boost. And then you it's so easy to gain stuff, because if you've ever gone down the naturally aspirated route, and I'm going off on a tangent. If you ever go down the naturally aspirated route, to pick up power, like if you take that Dodge motor, for instance, but any junkyard motor, a Vortex Chevy or a 350 Windsor Ford or anything LS, anything that we get from the wrecking yard, to add power, you have to change what I call the big three. So you've got to add a camshaft, intake manifold, and heads to really get the power up. So it takes a little bit of time and effort and obviously money on a naturally aspirated comment to kind of scratch away and get power gains. Now, sometimes, like for instance with the LS, we're a little bit spoiled because it already has a pretty good intake and it has a really good set of cylinder heads for most applications. So all we have to do is add a camshaft, and then we pick up big power. And then to get more power from there, after we've added our camshaft, then you really have to spend some money. You've got to get, a good set of ported heads if you've got a cathedral port. The nice thing, if you've got a 6-liter or a 6.2 liter that has rec port heads on it, you can get away with a lot more camshaft. And then in that case, on the NA power output, you end up running into a situation where you can't put any more camshaft in it because you don't have any more available piston to valve clearance. The cylinder head will support a lot more power if you could get more camshaft in it, and if you could get more intake manifold in it. But ultimately, piston to valve becomes a problem, and you have to put a different set of pistons in. So each engine family, specifically with the L, has their own thing that you have to adjust. The cathedral port stuff eventually runs out of cathedral port head flow, and this is less of a problem on the 4.8 and then on the 5.3. On the 6.0, the nice thing about the 6.0 is then we can add the LS3 head to that, or the LY6 head, which are not very expensive. And then all of a sudden you have a head that's going to support 650 horsepower or more on the right application. We've made almost 700 with a stock set of LS3 heads. But getting naturally aspirated power is a lot more difficult and more time consuming and more expensive. On the turbo stuff, if you put a cheap turbo on your thing, and when I'm talking cheap turbo, I'm talking about using the stock exhaust manifolds, merging the exhaust together, routing it so that it all goes through this. Like for instance, on this one, if we take a look at it, I'll show you. This one has the hooker exhaust, so that makes it easy. It's got the little crossover pipe. That pipe is right there, so it goes from one exhaust manifold to the other. But that's all stuff you can also build yourself on the cheap. So if you get all the exhaust going to your turbo and then you add boost to it, all of a sudden you're basically multiplying the power output. So even if you have a stock motor, you can get fairly big gains from that stock motor without changing the cam, without changing the head, without changing the intake. Obviously, you're going to have to work on getting more fuel to it and having a proper tune. But to go from, okay, I've added 7 pounds of boost and it's really, really good. As a matter of fact, it's about 50% better. And now I want to have more power. So do I need to add heads, cam, and intake? No, you just ran 10 pounds of boost instead of 7 pounds of boost. Now, obviously, like every good thing, there's a limit to how much you can add. But the nice thing about the turbos, especially if you, now I always recommend an intercooler, and the ideal thing is for most of these applications is if you have it in your area, obviously, is to run E85. E85 now is kind of like magic fuel because, and the moment I say this, I know that people are going to raise the price on it because it's inexpensive and it has a high octane and it has a cooling effect. So it has all the things that you could possibly want from a fuel. And speaking as somebody who's run lots and lots of race fuel and stuff, this is essentially race fuel with added cooling and without the cost. So it's really good stuff if you're running boost, and especially if you want to run a lot of boost. Now you can run reasonable boost levels on pump gas. You just have to make sure that your tune is spot on. And you have, and when you're running pump gas, like the 91 octane stuff that we have here, I even have guys say, well, how much can I run on 87? You shouldn't be running boost on 87. If you want to put cheap gas in it, keep your motor stock, keep it NA, and just drive it around. If you're going to add boost, you're going to have to pay for at least good fuel, at least premium fuel. Whenever I had any kind of factory turbo motor, I would put good fuel in, and I say that, and I've put regular gas in, or even intermediate gas in my wife's Mercedes, which has a turbo on it too, but that has all the knock sensors and all the safety equipment. And honestly, I don't know when she ever goes into boost on that thing anyway. So, but I digress. If you're going to have a performance turbo kind of application, a swap motor or an LS or any kind of car that you're going to put it in, you should at least put premium in it. If you don't have E85 and obviously you don't have race fuel, at least put 91 or 93 in other places in the United States. Put at least that in it. So because you want to be able to have fun. Now you probably could run 87 on something, but you're not going to be able to run a lot of boost. You're definitely going to need an intercooler, and you're not going to be able to run very much timing. And it's just not going to feel quite as good as it would when you put E85 in it. It makes a dramatic difference in the power, and it makes a difference the way the motor sounds. It's a lot happier. It's almost like if you've ever tested, and I've done this a lot, where we run an air-to-water intercooler, and we'll run like 80 or 90 degree dyno water through it, and then we'll put ice water in it. When you put ice water in it, and a good example of this is my Bonneville motor that we ran in the Civic. It was a turbocharged sub 2 liter V18 based motor with stage 2-ish kind of skunk 2 cams in it. It had a ported head. It had a 72 millimeter turbo. It had an air to water intercooler on it. So it was nothing radical, but we would run it and tune it, and then we would, when we would run it out at Bonneville, we would put ice water in. So when we did the tuning on the engine dyno and on the chassis dyno, I had to make sure that when we tuned it with the ice water in it, because it makes a difference. It wants to make a lot more power, and it sounds so much better and so much happier when you put the ice water in. And the same kind of thing happens when you have E85 in it. So when you run 87, you have to run so little timing in it that it's really going to be unhappy. And I don't know that I'd want to drive around under boost very long with so little timing in it, because the EGTs get really hot. I'd be worried about the exhaust valves in it. So there's a limit to what you can do on on really cheap gas. But about horsepower per PSI. So I've read lots and lots of comments from people talking about, I upgraded my turbo and it went from 30, 40 PSI to 60, 70 PSI, or horsepower per pound of boost. I know that a lot of stuff that we read on the internet is not 100% accurate. But here's how they're getting at that number. So if we have, for instance, a 300 horsepower motor, and we run 1 bar of boost, which is 14.7 pounds. If things are working right, and we've done our homework, and we have the tune right, and we have an intercooler, and we have good gas in it and stuff, you can double the power output. So that gives us another 300 horsepower. So if we divide 300 horsepower by 14.7, in this case, we'll just divide it by 15 because it's easy math. If we divide that by 15, it gives us 20 horsepower per pound of boost. So on our 300 horsepower motor, when we add our turbo to it and we do everything right and we double our power output, that turbo is providing on average 20 horsepower per pound of boost. Now, the reality is the first 2 or 3 pounds may provide less. The last 2 or 3 may provide less. There might be a sweet spot in the middle, depending on where the compressor map curve is and what your back pressure is and all that. And we'll get into some of that stuff tonight too. Some of the things that make that formula go away, that make it not work. But let's suppose that we get there and our turbo is now supplying 20 horsepower per pound of boost at 300 horsepower. Is there something that we can do to the turbo? I know that there are things that we can do to other things to improve that power output and improve the horsepower per pound of boost. But what do you guys think? Is there something that we can do to that turbo to now have it produce 30 horsepower per pound or 40 horsepower per pound on that 300 horsepower motor? I'm curious to know. There are lots of sharp guys out there that are watching and that are listening, and there'll be guys that watch this after the live feed. That you guys can answer this too. What do you guys think? Do you think that if you go from a junkyard motor and then a eBay turbo, and then you step up to something good like maybe this Borg Warner S480, even a high-priced Garrett or something like that, that you're going to go from that there's a way that you can go from our 20 horsepower per pound of boost on our 300 horsepower motor up to 30 horsepower per pound? Do you think that there's something that they can do to do that? I don't think that there is. I've never seen anybody do that. The way that I've seen people do that is the one way that we can increase the power output dramatically at the same boost level is by cooling the charge air. So if we go from water in our intercooler or air to ice water, we can make more horsepower per pound of boost, more than the formula suggests by having cold air. If we go to the extreme and have very, very cold air, you can get huge gains, but we're not talking about that. We're not talking about artificially cooling the air to sub-zero temperatures. That works really well, and the motor will really, really like it. You'll be able to run full timing, and you'll be able to run it on pump gas, and all kinds of good things are happening. The problem is getting it there, getting the charge air to 30, 20, 0 degrees, or even below 0 degrees. That would be awesome to be able to do that. That would make big power. Probably the best way to do this is not to start thinking about how I'm going to improve. Am I going to get a billet wheel? Am I going to go from a 7-blade to a 9-blade to an 11-blade to a 12-blade? Am I going to, all of these things that you can do to the turbo to improve the efficiency. Am I going to go to a twin scroll? And, all of these things that you can do. To me, the big thing is how much power the NA motor makes. That's going to help you dictate how much power you make per pound of boost. The other things that you do, like the fancy wheel and the twin scroll and all these changes that you can make to that, are a smaller percentage gain. You can't get the big gain with those things. What you can do is, if you don't have a good turbo and you have lots of back pressure, or you don't have enough octane to where you have to limit the timing, or you don't have an intercooler, all of those things take away from the formula. So you would be making less than the formula, and if you improve those things, you can now get up to the formula. But going beyond that, on our 300 horsepower motor, going beyond 20 horsepower per pound of boost gets more and more difficult. Making less than 20 horsepower per pound of boost on a 300 horsepower motor is actually very easy. We just take the intercooler off, put a bunch of back pressure in it, take timing out of all of the things that you can do to make it not efficient. That's fairly easy. So one of the ways that we can increase the horsepower per pound of boost is by making our 300 horsepower, having it be a 450 horsepower motor. We can even do an intermediate one. We'll go to 400 horsepower. Well, let's jump up to 450, and then we'll go back to the middle ground. So if we have a 5.3 that was making 300 horsepower, and we put a cam and heads in it, now it's making 450 horsepower, and we add our boost to that, and we double it, and we double the power output, obviously now we have 900 horsepower. So we've gained 450 horsepower with essentially 15 pounds of boost. A little bit less than that, but easy math. 15 pounds of boost, gaining 450 horsepower, is now 30 horsepower per pound of boost. So we've gone from 20 horsepower per pound to 30 horsepower per pound by changing the power output of our naturally aspirated motor. So the question again, Can we improve that even more by changing the turbo design? We know that we can make less with a bad turbo design, but if we have a reasonably good turbo design, and now we have a very good one, can we go from 30 horsepower per pound to 40 or 50 or 60 on a motor that makes 450 horsepower NA? And this horsepower per pound is a function of this formula. This is one of the reasons, and we talked about this a little bit last night, and I've talked about it again and again and again. This is one of the reasons that I love to run any motor that I'm going to run boost on. I like to run it NA first for the reasons that we talked about last night. I want to make sure that the motor is sound, that it doesn't leak, that it doesn't misfire, that it does all the things that it's supposed to do as the motor, NA, and then we add boost to it so that we know we can check that off the list and go, okay, we've added boost to it. Something is going on that came about from us adding boost. And the best way for me to do that is I like to run it with the injectors that I'm going to run when we add boost, so the same size injectors, ideally. I didn't do that on 4200, but I normally like to. Also, we want to run it with, you know, the intake manifold that we're going to use, the map sensor that we're going to use, so that when we're running it and we're doing the tuning, we can scale basically the NA power output and get that tune right. And then all we have to do basically is we take that and multiply by 2 for our first 1 bar of boost. And that will, it's not always like that, but that gives us a really, really good start. And then what I like to do when we're first running a turbo motor on the dyno is we'll tune the NA stuff, we'll take and we'll interpolate up, we'll double that, and then I'll add maybe 6 or 8 or 10%. Because when we load into it, I'd rather have it be 10 to 1 than be 12 or 13 to 1 when we do our load in. I'd rather have it be fat and have no timing and then adjust that rather than have it be lean and have too much timing. So we do that. That's how I go about tuning it. But the reason that we can basically double the NA fuel supply is because we're doubling the power output. Now, I know that the other thing that happens, and the reason that I'm adding a more of a percentage, is because it's going to take more fuel. We're running at a different air fuel ratio. When we're running NA, we typically run 13.0, between 12 and 13, wherever it decides it wants to make power, wherever it decides. A lot of times, like with these LS motors, they become insensitive to air fuel. So at 13 to 1, they make the same power as they do at 12.8 or 12.7 or 12.6 or 12.5. Wherever the richest point is that they make the maximum power, that's where I leave it, because in my opinion, that's the safest. When you're running the turbo motor, you're going to be running at 11.0, 11.5 to 1, something like that. Sometimes if we want to get really crispy, we'll run it at 12.8 or so. But usually it's, you know, it's going to be richer. So we have to add more fuel. So that's why I always put in that you know, the extra percentage to add a little bit more and to make sure that it's rich. So we want to start out rich, but the reason that that works is because our horsepower per PSI, because our formula, we're doubling the power output when we double the pressure. So if we made 20 horsepower per pound at 300 horsepower on our 300 horsepower NA motor, and we're making 30 horsepower per pound on our 450 horsepower motor, how much power, how much horsepower per pound are we making on our 400 horsepower motor, which is going to be in between those two? Well, I guess it's not really, huh? 300, 400, 450. It doesn't really do good math. It's easier just to do the 300 and the 450, because then it's 20 and 30. At some point in the middle there, you would be making 25 horsepower per pound, whatever we split the middle is between 300 horsepower and 450. So you would be making, you know, 25 horsepower per pound. And then if we go up, let's say if we put it on a 600 horsepower NA motor, because that's another thing that's easily divisible by 15. If we have our 600 horsepower motor, we're making 40 horsepower per pound, and you can keep extrapolating that up. And that's one way for you guys and for everybody to make more horsepower per pound, is to put it on a bigger motor. And so when I have this discussion with people, they're like, "Oh no, Richard, you don't know what you're talking about. My special turbo will make 50 horsepower per pound." And the thing is, they will. The same turbo, like this turbo, will make 50 horsepower per pound of boost, but it'll do it on the right motor. It's not going to make 50 horsepower per pound on our 300 horsepower 5.3. It's also not going to do it on our 400 horsepower 5.3 or our 450 horsepower 5.3. It's not going to make 5 or 50 horsepower per pound of boost. The best way to explain this, as always, is to use an extreme example. So if I take my 1 liter Chevy Sprint motor, which was rated at a whopping 70 horsepower with boost, meaning it made probably like, 45 or 50 horsepower NA, no matter what turbo you put on there, on that little 1 liter Sprint motor, you could put on a Formula One turbo that costs $80,000. It's not going to make 50 horsepower per pound. It can't do that. That's not part of the laws of physics as we know it. No amount of super efficient turbo is going to be able to do that on that motor. It just isn't possible. So there definitely is a correlation between the amount of power the motor makes naturally aspirated and the amount it makes under any given boost level. And therefore, that dictates the amount of power that it makes per pound of boost. So that's the way that I look at this. Because a lot of guys, I've been to lots of dyno shops and talked to endless people online and other tuners and guys that talk about power and all kinds of stuff. And it's all great stuff. I love learning from other people and talking to them and interacting, and all that's fantastic. And some guys that's their thing. How much horsepower would it make per pound? The other issue here is the thing to look at is when a lot of guys like to track that. Okay, at 7 pounds, it made this much. And then when we went to 8 pounds and 9 pounds and 10 pounds, it did this much. And then they calculate the gain from 7 PSI to 10 PSI. And then they divide that. Okay, it made this much horsepower per pound. And then when I went up this much, it did this much. But one of the things that throws this off is that most people that are tuning, as we go up in boost, we go down in timing. Now, there are two schools of thought here and 2 things to think about. One is that as you go up in boost, there's more cylinder pressure. You don't need as much timing. You definitely want to take that away from a safety standpoint, but also really you can take it away from an efficiency standpoint. But it also might mean that you didn't make the same horsepower per pound at the higher levels with the lower timing than you did at the lower levels with the higher timing. So that can have an effect. If the air fuel that you had on your 7 PSI run is not exactly the same as you had on your 8 or your 10 PSI run, the amount of power gain that you got per pound of boost might be different. And then so when you're measuring that, you're like, oh, this thing is not in its efficiency range. a difficult statement to back up, having never seen any sort of compressor map and basing it solely off of that information without taking into account all the other things. If you take a look at what happened when we were running the 4200, where I was showing you in that video, and if you haven't taken a look at that video, you need to, where I was showing you that when we put heat in the turbo, it changed the response rate. And so it changed the effectiveness of the turbo. If you're not monitoring all that stuff and trying to exactly duplicate all of that stuff, your results may vary. And so let's say you're 5 or 6 horsepower off on one of them because of that. Maybe you let the thing idle longer. There are a lot of things to take into consideration when you're dyno testing. And if you're doing testing at the OEM level or for the Society of Automotive Engineers, then they obviously have to make sure that all of that stuff is exactly perfect. Most aftermarket people like myself and other people that do testing, it's really hard to do it at that level because, and I'm not looking for the last 1 or 2 horsepower. That's not critical to me. I'm usually looking for big changes. If I put something up and make a change and it only changes it by 2 horsepower, to me, that's the same thing. It might not be for an OEM level guy, and it might not be for the Society of Automotive Engineers, and it certainly wasn't for us when we were doing Engine Masters, but that's why that kind of testing takes so long. It takes so much time to ensure that everything that you do is exactly repeatable. And you saw when we were doing that test, I'm not really concerned unless we're doing a test exactly on response rate. I'm not that concerned with the response rate because once the turbo got up and everything got hot, then the thing was repeatable even up at the top. We can work on the response rate, and I can make runs where I make 3 runs in a row and the thing's nice and hot, and then we count the 3rd run or the 4th run, and then duplicate that procedure every time if that's the thing that we're looking at. But it isn't always. So, you know, sometimes you get variations from the way that you test it, and that's another thing to think about. While you're testing during the day, I know that there's a correction factor from the dyno, but maybe the changes, maybe the temperature changes. You know, there are a lot, maybe a cold front comes in, or a low pressure zone or high pressure zone. All of those things you have to be thinking about when you're trying to calculate how much horsepower you're making per pound when you're going up in successive steps. The other thing you need to look at is when you're going up in successive steps, if you're gaining more horsepower per PSI at 10 pounds of boost than you are at 20 pounds of boost, we've already talked about the air fuel and the timing. But the other thing to think about is you need to start thinking about charge temperature. Where is your intercooler efficiency at? Can it support that flow rate and that temperature drop? Now, what is the temperature drop across your core? So are you having to, if you have now 2 pounds of drop where you only had a 1 pound of drop at the lower boost level, the intercooler now is robbing some of that efficiency. It's actually not the turbo and how much horsepower it can support per pound of boost. It's actually some other thing in the system, which is, you know, again, another consideration that you have to take into account. In the big picture, as I said from the beginning of this, add a turbo and add boost and good things will happen. But when you start wanting to measure horsepower per pound of boost, the big thing for me is the power output of the NA motor that you're starting with, which is why I want to do the Barra, and which is why I want to start out with an NA version, so we know that how it's tracking per pound of boost. And I do that for any motor. And then so the motor that you choose obviously dictates how much horsepower you're going to make per pound of boost. And then look at the other things. Then look at, okay, how is my turbo doing? How's my back pressure doing? How is the pressure drop across the intercooler core? How is my temperature gain? Like, how much heat is the intercooler taking out? You can start looking at all of those things to figure out, hey, look, I can, even if I put a bigger turbo on there and one that was more efficient and had more flow capacity, if my intercooler is still robbing me of 3 pounds of boost, the turbo is really not where I need to look. I need to look at that intercooler, obviously. The other thing is to look at on the turbos, when you're talking about efficiency, you got to look at the cold side and the hot side, because and this is more true for guys that are running like drag race applications where they're trying to max the thing out. There are guys that just, you know, let's just cap the wastegate, we'll put the skull and crossbones on there and see what that turbo will do. And when they're doing that, you have to be concerned with which side am I maxing out? Which side is the problem area? Did we max out the flow rate of the compressor, or do we max out the flow rate of the turbine? What is my back pressure? What is the flow potential of that hot side? What is the flow potential of the cold side? If you maxed out one of them before the other, you can make a change of one and improve your situation. For some guys that are in class racing, they don't allow that. So you have to get fairly creative about some of the stuff that you're doing. But if you're looking to do that and you're going to upgrade the turbo, have information so you don't want to just go, oh, okay, well, I need to go from an 80 miller to an 85 or a 90 or a 96 or 93. But I'm going to keep the same hot side. Well, if the hot side was the problem, then you're not going to get anything from it. You're just probably going to make the situation more laggy because you'll have too big of a cold side. So keep all of that stuff and take all that stuff into account. And the other thing after, obviously, is the exhaust. After dealing with the hot side, the one thing that helps with turbos a lot is a very free-flowing exhaust. There's this notion out there that somehow got started that you want a small exhaust to improve the response rate. It'll make the turbo a lot more responsive. The opposite of that is actually true. You want to put the biggest exhaust you can, the biggest free-flowing exhaust on your turbo, and that will make it the most responsive. So big exhaust to get the most power out of it, and you don't want to choke it down from the exhaust. Now, you know, on some street applications, you might want to run mufflers or dual exhaust or that kind of thing, and you can certainly do that. But that's why guys, you see turbo guys running at the track, they've got the big 4.5 or 5 inch pipe, you know, coming out of the fender well. And the reason that they're doing that is because the turbo really likes a free-flowing exhaust system, which is why you can kind of see this one over here. That's important when you're doing testing. You don't obviously limit it, because then you're going to skew the results based on what you're doing and what thing you're limiting. So now that I've extolled the virtues of making the motor bigger or more, and you don't even have to make it bigger, you can make it more powerful. But the thing is, you shouldn't expect the same horsepower per pound on a 4.8 as you get on a 6.0 if the power is different. And obviously you'd want to look at hot sides for those different applications too. So let's get to your questions, see what you guys are doing. Okay, yes, get the thumbs up going. We have 237 and only 100 likes. So get them like buttons going. And I'm going to grab something. You guys can take a look at this. I'm going to grab something real quick because I'm going to be running to more testing on the 4200. So I'm going to be raising money for the. I've got to buy. Let's see, what do I got to buy? I've got to buy springs. I've got to have the heads done. We're probably going to have to buy valves. I've got to get, I'm sending some cams off to the guys at Schneider to get those ground, head studs, all kinds of stuff. But I'm not asking you guys for money. I've got stuff that I want to sell, so I'm going to grab some photos of some stuff. 2 motors. One is the Cadillac. It's not assembled here. It's not assembled yet, but just come get it, and you can have the Cadillac. But I'm going to go grab my phone so we can take a look at some of the photos, and hopefully you guys, somebody out there will be interested in picking these parts up. The other one I have is a aluminum-headed small block Ford, but I will be back momentarily. Whoa! Okay, I'm back. I got my little magic box here. What do we got going on? Okay, so I'll put this up. You guys can hopefully see that. And that's like, it's like terrible on that. Let me see if I can get a better view. There we go. Small floored, Extreme Energy 274 cam. It's a 50 ounce 5.0 deal. It won't come with those valve covers. I've got some cast aluminum ones. I'll put a dual plane intake on it. We lost our feed there. I'll put a manifold on it. If you guys are interested in that, take a look. The other one I have is the, let's see, where are we at here? See, here we go. Cadillac, she's all wrapped up. The heads are all wrapped up. It's ready to go back together. If you guys are, anybody's interested in the 500-inch Cadillac, it's all rebuilt basically, let me know. Yeah, turbo in the house. So I'm going to try to get rid of those and get some room. I still wanted to do more testing on the 302, but I've done a bunch already. It's a good little motor. It's run on the dyno. Cadillac, $600. And for the Ford with an intake manifold on it, let's say $1,800. You probably couldn't buy the heads for that, so it's a good deal. And the Cadillac, like I said, I'm sure I spent more than that on all the machine work. So if anyone's interested in that, let me know. Send me an email. I'm going to go ahead and put my email address down here. Let's see here. AOL.com. There we go. The Ozman. got some gas money. Thanks, man. Let's see. I just watched your ring gap video you posted a year ago, and part 1 and 2 are more recent videos, and all the awesome videos in between. Your opinions: 5.3 or 6.0 for boost applications. I'm in Florida. Mika, either one of those will take a lot of boost. I mean, we made 1,300 with the 5.3, and guys are making a lot more than that, especially on the Gen 4 stuff. That was Gen 3. So if you have a 5.3 with Gen 4 internals in it, and you put a cam in it and boost in it, you can make about a bajillion horsepower with that. A 6.0 is going to make more. It's going to be more torquey. You just have to make sure you size your turbo right for the 6.0 because it's going to have more back pressure because it's bigger. Half fast. Do you have any stock LS lifters laying around? I'll bet that I do. Yeah, Sean, it's a really good deal on a Cadillac. I would like to put it back together because then it probably would be worth double that or something. But I need the room and I need the time and I need the money to get all the 4200 stuff and the Barra stuff. Julius, how are you going to get that Ford motor to Australia? And I don't think I do. I have Julius, if you're interested, and I have the custom intake manifolds that I did for the modular stuff. I can just send you that do you have a 5.4 base motor or do you have a 4.6 base motor? And these were done for the like 03 Cobra heads, I think. And I also have a set for B heads. So I did you know, down leg runners, and then we had the dual plenums on it. So it's fancy dual throttle body deal. Snafu, is porting aluminum Speedmaster 351 Cleveland heads worth the investment, or would be money better spent on some TFS Cleveland heads? I've never compared those two. We ran a set of ported Speedmaster heads from Bryce over at Dr. J's when he was in business, and they worked really well. They flowed very well. So I know that those, when they're worked over properly, do pretty good. Yeah, Mika, if you've got 5.3s, just, you know, ring gap, head studs, springs, cam, boost, you'll be good. Let's see. Have you done any testing on a long rod 5.4 or 306? That I kind of want to do that next. I want to build two of them, or at least two rotating assemblies. One with a 509 rod and one with a 5.4 rod. Let's see. Turbo Tony under boost. How much horsepower can the stock truck coil packs with heat sink support? How much boost can they support without the spark being blown out? One of the problems you had there, I don't know about those coil packs specifically. We normally run like the LS3 style, but unless you have the ability to manipulate the dwell time, I don't know where they would run out, because if you only have 1 millisecond or something, it's not going to work as well. Do you have any plans on making a project engine with an LS4? I do not. Easy upgrades for a 2020 6.2 liter. Probably a tune on that. Yeah, 7875 on the 6 liter will work good. Just bought a Corvette servo. I'm looking for a comparable boost controller to the TC1 that is used when testing the 4200. That's just a 3-port, so it should be easy to come by. The guys from TurboSmart have them. There's probably lots of them out there. Take a look. Matt over at Sloppy, I think, has some that he's done, but it's pretty easy to do. 6915 long rod in my Pontiac. That is pretty good. That is pretty good size. Let's see. By boat, like I get everything. You have a 5.403 Cobra head, so yeah, very interested. The problem is, I think that the intake, I need to look at the intake. The 4-valve intake might be 2 pieces, so it might go on a 5.4 just as well as it goes on a, I think it does, because I think we tested it on the 5.4 Sullivan motor. Well, trying to maximize VE in a Honda F20C GT3582 at 20 psi. I gain VE by ceramic coating the pistons. Low tension rings, crankcase ventilation, quench, welding the combustion chamber, ER7s. All of that should be good stuff, but did you compare it back to back from what it was before at the same boost and air fuel and timing and temperature and all that stuff? The ceramic coating of pistons should help keep some of the heat in there. Durham, bore times 3,000 ring gap. No, we do 6 or 7. Have you done anything with the 1ZZ Corolla Matrix engine? Is that the same one that's in the did the Scion use that? Mika, what's up? Thank you very much. Hi, you would. Thank you very much. Did you guys have questions? Oh, what Mika did, yeah. What happened to Sloppy Stage 2 versus the World? I haven't done the turbo version of that yet. Boost is relative, but what about air density versus horsepower? Well, you have to have something to measure the air density. Yeah, and the dyno will tell you that the power output is probably the best measurement. Gail Banks always talks about manifold air density. Let me guess, Gail is selling something that measures the manifold air density. How come we never talk about that on the gas side of things? Michael, Australia. Like my Australians. The Aussie boys, what's up? Thinking about a VSR 7875 on a 5.7 Hemi. That works good. We ran I think we ran an 80 millimeter comp turbo when we did the, if I remember right, or the Precision 7675 when we did the Big Bang on the 5.7 Hemi. Noodles, I thought Westech was kicking you out of there last night. They, off of the dyno, they had a big block that they had to run this morning. And they put it up yesterday. I haven't run any testing on the 7.3 Godzilla motor. Actually, when the engine is back together in the car, I will send you some videos of the setup on the dyno at Haltech. Cool. Yeah, I'll check, Julius. It's been a long time since I looked at it. I'll check and see if it is a 2-part thing. I think that it is. Richard, have you ever done any testing on a Datsun L series engine? I have an L18, 74 620 pickup, very cool. With a Cam Makuni, 2 Weber 45 DCU carbs, and header with a Jacobs ignition. I have a 71 240Z. I also had a 260Z, and it had side draft Webers on it. It had a cam in it. It had a little bit of porting done to the head. So it had stuff that we had done, back in the day. I wish I would have just turbocharged it. I didn't know anything about turbos back then. Yeah, it's hard to measure air density because you need to. I think you need to combine the. You need to combine a mass air meter and a map sensor. I think that's what Gale does. I think that's what Gale's thing is. How good is the GT45 long term? I've had nothing but good luck with the one that I have. I have 2. Does the power potential per PSI change with the octane of the fuel? Definitely it does. That's what I was talking about earlier, is that if you're running 91 or 93 octane, you're not going to make nearly as much power because you can't run the timing in it. And if you run E85, you're going to make even more power because the E85 by itself is going to add power. And then you can also add more timing to it and make even more power. So that's all we got to do is say the word dyno and then the lights go up. Anyone know? Mark probably knows this. Anyone know how many cc's the 4200 chambers are? Big Bang LV1, LV3 someday. I want to see how strong those aluminum blocks are. Is that the little V6, Travis? We're going to do that. I'm going to keep bugging Brian Tooley until that happens. Because they can run LT stuff back there and they can control variable cam timing. They've done the L83 and the L86 and the LT1. And so there's no reason that we shouldn't be able to run a V6. Tuner Dad, I've actually never tried grits that I can remember. 1ZZ came in the Chevy Prism, Pontiac Vibe, Lotus Elise, plus the Corolla type Toyotas. Okay, I haven't run one of those. I don't even remember doing any chassis dyno stuff on that. What would you say is a safe amount of boost on a stock bottom end 5.3? Well, the one that we did made 1,300 horsepower, and that was at 26 or 27 pounds. So if you do what we did, you can do a lot. If you're just trying to run boost on one that you didn't open up and put ring gap on, there's no way to tell what's a safe amount. It's whatever that was right before you broke it. So somebody made a comment on up here that I wanted to look at. So everyone seems to agree that torque is what breaks rods, but assuming the same rods are being used, what engine would be more at danger? 500 horsepower NA at 15 psi equals 1,000 horsepower or 330 horsepower. The cylinder loading would be the same if the torque is the same. The cylinder pressure should be the same. What you run into with the higher boost level is much more chance of detonation because you have higher temperature. Because at 15 psi, the discharge temperature coming out of the turbo is going to be much lower than it is at 30 psi. And unless your intercooler drops the charge temperature from the 30 psi down to the same as it did with the 15 psi, you have a higher charge air going in. Is there any difference between the LS7 lifters and the stock Gen 4 lifter as far as pushrod length? I don't know. I kept meaning to ask Brian that because that question has come up. I don't know if there's a cup height difference on the LS7 lifter. I've actually never used them before. I would like to see a test, dyno test on boosted motor on E30 versus E50 versus E85. That's probably something that can be done. I was told by some guys that once you get past E50 that there's no change after that. But I would think that from E30, I would think that there might be a safety change from that. What's your opinion on spark plug heat range and gap for boost? Tons of opinions out there. We do 6 to 7 thousandths per inch of bore, and I do. And then what was the other question? Plug heat ranges. I run an 8 or 9, sometimes 10 on really high boost levels. So we run the plugs fairly cold, but we run really tight gaps. So we run 18 or 19 on the plug gap. So the plug gap, here's a rule of thumb, and maybe this is a new t-shirt. Real turbo guys have the plug gap smaller than the ring gap. So ring gap is greater than plug gap. So that's got to be a new shirt, right? What brand, GT35 or GT45? The one that I have is from DNA, but I think that there's a lot of guys that source the same turbo and then put their name on it. Let's see, looking to turbo my F-150, 3-valve, what budget turbo? Get the GT45. Let's see. Dylan is saying that the cup height is the same. I thought that it was, but I don't ever remember measuring directly that. Karen is saying the 7875 is a little small for the 6-liter, and it's going to depend on what power level you want. If you're trying to make 700 horsepower, it's going to work pretty good. If you're going to try to max it out, then that, like I said, you're going to run into some back pressure issues. 72 Ford LTD, 6-liter, 374 rods and pistons, 10-to-1, 706 head, Summit Stage 2 turbo cam, 3500 Circle D, 4L80, switching from a built 75mm T4 to an 85 102 T6. You're going to change the spool time. Definitely. What is the hot side of the 75mm? I'd say, I'm going to say it's going to be, I don't know, 400 or 500 RPM. Rumble Canada, how do guys get V6 turbo cars to 1,500 to 2,000 horsepower? How do engines handle that much power? Well, they're dedicated builds, and in most cases, they're going to be, a dedicated billet block or some sort of aftermarket block. They're going to have a billet crank, forged rods. They're going to have really, really good stuff. And then you're going to try to have really good heads, a camshaft, an intake manifold. All that stuff's going to be sized so it runs lots of engine speed in a small displacement motor. Engine speed, and then power output, and then boost. For max effort drag, Gen 4 6-liter, would you suggest a twin 76mm or a single 8891? I think a lot of that's going to be packaging. Are you trying to make 2,000 horsepower? Because that's what 276s are going to kind of be able to do, and maybe a little more depending on which ones you pick. Sean, put an arc welder in there, and that'll get it. That'll get things lit. Daniel, we ran 4 different turbos on the K24, including one from Force Performance. So take a look over there. He's got good stuff too. Have you ever run compound turbos? Yes, I have. There's a video up on the channel that has compound turbos. I don't think it's necessary on an LS, given the amount of power that we've made from singles and twins. I don't see the need for it. In diesel stuff, guys do it a lot. Yes, I have been looking at the Barra stuff. I was watching the one where they were trying to make 2,000 horsepower, and then I saw the ones from here in the States. I think that they were at 1,400 or something. Noodles is out. Yeah, if you pick an engine family where they've had enough strength built into the motor from the factory, you can use factory stuff sometimes. The 2J is a perfect example of this. Somebody pointed out the Ecotech stuff deal. I know I've seen some of the Roush builds that they did back when they were running those in sport compact car racing. The power outputs that they make were tremendous. Route 66, I hear you. What's the highest horsepower you've dynoed from a 4-cylinder? The highest power I've ever made was my B series, but we only ran like 730 horsepower with that. Yeah, Julius, 2 of those GT45s would work pretty good. Let's see. Thank you very much. Also, 2, I'm still waiting for your book and your Killer Bee shirt. My wife's excited. Daniel, were you the guy that I had to change the address on? Because all of that stuff's still sitting at my house since I've been down at Westech. 5.4 4-valve Aussie mod motor. Okay. When increasing power, how does it affect your stall? It'll raise your stall speed. So like if you have, the example that we always use is if you have a small block and you have a 3,000 RPM stall, and then now you make it a turbo small block or a big block, that same stall converter is going to stall much higher because it has a lot of torque being applied to it. Yeah, the Garrett stuff is really, really nice. There's no doubt about it. So if you can afford to get the good stuff, you get the good stuff. Yeah, well, Tom, I mean, there are guys doing 1,000 horsepower stuff, I think, with B series. There weren't a lot doing it when we did it back in the day, but I think that was 29 pounds, and I only ran it there because Mahovitz loaned me one of the 76 millimeter turbos that he had, one of them that he had from his mod motor car, and we ran that on the dyno. I've never run that turbo in the car. We only ran a 72 millimeter, and I've never run anywhere near that power. We've only ever run, I think the most boost we've ever run out at Bonneville was about 17 pounds. And I didn't even get to run the full 5 miles at 17 pounds. That thing at 20 pounds for the full 5 miles, I'm sure would have been a 240 mile an hour car. 4G63, like the old school Eclipse and those kinds of things, I haven't done the Evo stuff and the Eclipse stuff. I've only done on the chassis dyno. I haven't run any of those on the engine dyno. Tom, I just answered you on the turbo. Do you reference boost pressure from the wastegate off the turbo port or the intake? I usually do it off the intake, and that's one of the tricks, though. One of the upgrades that I did on my Sprint is that they had it referenced off the turbo, and when you reference it off the intake, your boost will go up because you're getting rid of from the turbo. The boost is going to have a higher boost coming out of than it's going to see in the manifold. So by removing that wastegate reference line and putting it on the intake, you're going to keep the wastegate closed longer until it reaches that prescribed boost in the intake and not just at the turbo. So now the turbo will be up whatever the loss is. Let's say that there was a 2 psi difference from coming out of the turbo, going through the intercooler and all the length of tubing into the intake manifold. Now you've just raised your boost 2 pounds. It works really good. Durham, thank you very much. Daniel, were you the one that I sent the message to that I needed, because I tried to mail somebody's, and there was the post said that it was a different city than I had on the address. Let's see, 5.3 Hobby Stage 2 TBSS 4L80 FT1 3500 converter, street truck versus racing billet S480 or 7875. How much power are you trying to make? I mean, the S480 will be more power potential, and I think that you have enough converter there for the S480. Have you ever considered a small block Ford with the 6R80 swap twin turbo versus Pro Charger? No, I never. But we've run lots of tests on turbos versus Pro Chargers, and that video is up where I compared on the mod motor, and it works the same on every motor. We compared the roots blower, the twin screw, the centrifugal, and the turbo, and I did that on a Honda B series. I did it on a small block Ford, and it's always the same. The boost curve supplied by the centrifugal blower is one thing, and then a roots blower is one thing, the turbo is one thing, twin screw is one thing. They always do the same thing. Pro Charge Mopar, you need to start from the beginning. Terrence, I don't think you need short travel lifters on most 5-liter HO motors, because unless are you trying to really spin the thing and make lots of power? Does connecting the manifold line rather than the turbo create a vacuum leak? No, because it's sealed on both sides. If it's just going to your wastegate controller, well, in our case, it wasn't going to the wastegate controller, it was just going to the wastegate. So running a line from the intake manifold to the wastegate, both ends are sealed. One is in the manifold, and one is at the wastegate. So there's no vacuum leak there. What ring gap would you suggest on a stock bottom end 5.3, Gen 3, 10 to 15 pounds? That's a big range. Stage 3, TSP turbo cam. We normally do 28 or so on the ring gap. Do you use oil feed restrictors? We do when the turbos come that way. Sometimes we do and sometimes we don't. Yeah, just try it and see what happens. If you move it and you like the results, then that's good. And if you don't, then you change it back. It's really easy. That's a simple swap. I think we picked up about 1.5 pounds on the Sprint when I did that. Is a 7865 too small for a 5.3? It depends on how much power you're trying to get. You're going to get to the limit of the hot side on that before you get to the limit of the cold side. Have you run into valve float on the 4200? I don't know. The heads on the Ford are blueprint heads, and they might even be ported. I'll have to look and see. Daniel, take a look at the test I did on the LS where we changed the push rod length. That does the same thing. It changes the preload on the lifter. What's your opinion on Q16 fuel? I don't want to get it on me, but it will pick up power. You have to, on carbureted stuff, we have to rejet for it. Would a transmission or a diff that breaks on 500 foot-pound torque on it? He's trying to measure the difference between the question went by. He's trying to compare loads on the same torque output or the different torque output and the different weights of the vehicles. Yeah, Julius, I actually thought about that. I'll show you guys a photo of the intake manifold. Julius wanted to know if I could make an intake that has a center-mounted throttle body opening and one on the end. And we were thinking about that when we were doing this. The other thing I did was, one of the tests I wanted to do, and it's really kind of esoteric, is we have radius entries, obviously, in the runners inside the plenum. I'm going to show you a picture of what I'm talking about. We'll do this. We'll do this again. So, there you go. So that's going to be the adjustable intake manifold. But the interesting thing is, inside the plenum, we have come on, camera. Don't freak out on me. Well, you just kind of got unhappy, didn't you? Let's see. Come on. So on this intake manifold, we have inside the plenum, we have, let's see. Let's go down a little bit. There we go. We have the radius entries inside the plenum. But what I wanted to find out is, does it make more power with that radius entry all the way against the floor or with some kind of standoff? But the thing is, you have to be able to do that without changing the runner length. So right now, the runners are a slip fit in the plenum. So we can slide the plenum and run a test each way and find out. And obviously, we're going to do this NA and not under boost, at least initially. So we wanted to find out if there's a change from the position of the runner relative to the plenum floor without changing the runner length, because we know if we change the runner length, it definitely changes the power. So that will be an interesting test. I've done lots of testing with moving the throttle body to different spots. I have a manifold that I did where we put 3 throttle bodies on it, just opened 1 in the center, opened 2 on the outside, opened all of them. And once you get enough airflow, it didn't change anything in the power. I don't think we'll see a change from, at least on the NA motor, if the throttle body is big enough. I don't think we'll see a change in power from repositioning the throttle body. What you might see under boost is a change in distribution, but we'd have to have individual O2s on all of the holes, which could be done on the long runner header that we have. So lots of good stuff going on there. Does dry subwelling fix oiling issues for good? Yes, it usually does. It's better for us if you're out of focus. Nice, Steve. Thanks, appreciate it. Nothing but love there. Let's see, I miss muscle busting and fast forwards. I do too. I really liked doing stuff with Campy and Evan. How much to set up your own dynos? Sort of Venmo and we'll donate. You guys don't need to pay for that. I like what I'm doing. I love the guys at Wastegate and I love coming down here, and they're set up like people wouldn't believe what stuff they have here and what different things I can do. I've been to other dyno places, and it's a lot more difficult than other places. I know when they're showing when you go to YouTube or go on the line. I love that movie. When you go on the line and are looking up the hookup for a 3-port controller, it shows you hooking that up to the boost reference from the turbo. And I don't ever do that. We hook it up from the intake manifold. And also when I do that, a lot of times since we have 2 gates, I have to split that. So I've got T's and fittings and things going everywhere. And sometimes it's hard to remember which fitting is going where. And am I going on top of the wastegate? Am I going on the bottom? Where's the other T? You know, it's a lot of stuff that's going on. Multi-layer steel, yes. Will a Gen 4 4.8 with 862 head spool a billet Garrett 94mm turbo? A 50 shot will definitely help. That's an awful big turbo for a 4.8 liter. And then make sure that you have a long runner intake. That will definitely help. And then not a big camshaft in it. And then if you are going to do all that, then put like a 4,000 or 5,000 RPM stall converter in it, and then you're all set. Yeah, and then we run a separate line from the intake to the blow-off valve. But they're all getting the same, reference. It's all from the intake. It's all from the intake manifold. But we try to separate them. This one's taking from over here, so it doesn't hear any of the interference that's going on over here with our little manual bleed valve or our 3-port deal for the TC1. Neil, I'm actually not a veteran, but thank you. And I thank them for my service. Both my father and my stepfather did serve. Is there a dual plane equivalent of a dual plane for an inline 6? I don't think that there is. Two tours in Iraq. Awesome. Thank you very much. Is the inducer the same size front to back on that turbo beside you? This one? I don't remember what the hot side is, if that's what your question is. Obviously, this gets bigger as it goes in, but I don't remember. I'll have to take a look and see. I don't remember what the hot side is. I I want to say it's an 83 millimeter hot side, but I can't swear to that. That might have been the S475s that we ran. Yeah, Julius, you can do dual runner intakes, and that's fairly common. The other thing I've seen, if you take a look, I think Peugeot did dual plenum intakes on six cylinders as well, with a valve in between, kind of like we saw on the 462 valve truck mod motors. They did that with 6-cylinder stuff. So if you do a dual runner and a dual plenum, you probably can get some cool, like, resonance changes in there. Julius, thanks for your service. 5 years, nice. I created my own special vacuum link with a T-fitting. We used to do that. That's how we would control them. We'd either use the fish valve, the little aquarium valves, or if we didn't have those, you just start stacking the vacuum tees and leave them open. What engine is the Nova really getting? We don't know. Tom, you're going to join the French Foreign Legion? Did you know that the 2500 Ford 6.2 is dual runner? I did not know that. Look over here. That Hemi right there, that 5.7 Hemi, is a dual runner. Pretty fancy Hemi stuff. On a dual plenum setup, do you have to be linked together? I've done lots of testing every which way. I had a connection. We had different size connections, because when we were changing the runner length, I had them in a V, and so they would get farther away. So we had to make the connection longer. We tried connecting them in different spots. We tried not connecting them. It was a lot of cool testing. The Nova's getting a Triton V10. Yeah, Julius, that's a good idea. The changing the RPM that they open. The Acura GSR was like that. There's a lot of manifolds that are like that. Oh, the 7MGE did. Cool. Yeah, you don't see too many aftermarket deals. The one that I have, and that came from Ford, is the FR500 intake manifold. That's a dual runner magnesium intake manifold. It's pretty cool. Mr. Hansen, so I live 4 hours away from any race gas or 85. Would you trust direct port water meth and 91? Yeah, you can do that. Guys are doing that. Any other tricks to run high boost? Try to keep the charge temperature down. Make sure you have cold air going to the turbo and then happening after the turbo also, to have a good intercooler. Just hopped on. PSI isn't the same as volume. No, it's not. Pressure and volume are different things. That's why we have mass air meters. And temperature. I know, Mark, it is missing two. Unfortunately, Mark, I can't flow that. I can't flow the 6-cylinder head because all of the valves are bad. That's not gonna tell me very much. When the seats are bad and the valves are bad, it's really hard to make good flow numbers. And I already took both 6-cylinders down to the machine shop today. Took them down this morning. All right, Julius, man, thanks. When I get back, I'm gonna. I got some stuff I'm gonna send you. Scott, I have a 4-inch cold side piping, but it necks down to 3 inches into and out of the inner core. Okay. I don't think you need to have 4 inches before the inner core then. I've been looking at the high ram, but I think there's a cheaper sheet metal one. There are definitely cheaper ones, but like the sniper stuff, those and all of those eBay fabricated manifolds don't make as much power as the high ram does. But make sure that you want to make power at high RPM, because that's what a short runner high ram is going to do. Can you give a quick overview? It's a really long thing. We're talking about horsepower per PSI, and the best way to change how much horsepower your turbo provides per pound of boost is to change the power output of the NA motor. So if you have a 300 horsepower motor, you're going to make 20 horsepower per PSI. If you have a 450 horsepower motor, you're going to make 30 horsepower per PSI. And a 600 horsepower motor, you're going to make, what did we say that was? 40 PSI. That's the best way to do it. And having the double wazoo turbo is not going to change that much. You can change it with really, really cold air, though. If you can get your charge air down below 0, then you can make some surprising power numbers. Anyone in chat know a rule of thumb on when it's worth the money to upgrade to from an HEI to a full MSD type system? What is the power level that you're doing? How much power are you trying to make? We make lots of power with an HEI, especially on an NA motor. Would the air condense in the inner core? Maybe 4-inch would slightly help. Sure. I don't know how much slightly is, though. If I was going to put a turbo on the Magnum engine, which one would I put? We probably would try, I would obviously try the GT45 because we wouldn't run very much boost on the Magnum, but the 78, 75 would also work well. What PSI or charge temperature before needing an inner core? You need, if you add a turbo, you should put an inner core on it. So it should be right away. Anything over 0 pounds of boost, you should have an inner core. I say that having run my Vortex supercharged Mustang for 85,000 miles at about 7 pounds with no inner core. Question: bigger valves, stock cam versus stock valves and a bigger lift cam. So are you talking about just changing the lift? Because if you're not changing the duration, the lift might not do much if you still have the stock duration. The other problem you're going to run into is probably valve float, because that's going to be a real aggressive ramp rate with, say, 190 degrees of duration, and you start going up and lift. It's going to make things very difficult. Yeah, Mark, Jerry does have some heads. I'm probably going to buy one of them from him. What size cam can I run in 86-302 with a flat top pistons? No valve release before I have piston and valve clearance. It's going to be small. It's probably going to be smaller than the 274. Did you ever find a 2.2 or 2.4 turbo? Not yet. So if I had twin turbos and I ran each turbo through its own 1,500 horsepower intercore, do you think I'd essentially create a 3,000 horsepower intercore? Yeah, if you have 2 of them, right? That's easy math. Let's see, I installed a kegger gasket on a few weeks ago was sucking oil. 2000 model. I think the one that I have is from a 98. Tipsy, the thing is, there's a big difference between, and I don't know what kind of forced induction you're running. On my Mustang, we ran a Vortec. So when you'd roll into it, there'd only be 1 or 2 pounds. And it didn't have peak boost until the end of the RPM range, 6,000, let's say. So that creates a lot less torque and is a lot more forgiving on the street. I even ran it with 87 octane, but I could drive around and not go into boost. Most people can't do that. So a centrifugal is going to be much more user-friendly on pump gas than a turbo is, because a turbo, when it comes on, is going to have another 100 or 150 foot-pounds of torque compared to a centrifugal. So it's going to be a much different animal. You drop your plug gap from 35 to 30. I think you should go down more than that. Yeah, Flexall. Jeremy definitely is interested in doing the head, so we're probably going to send him one. I think Calvin already has. Terrence, what is your theory about the difference between a long rod 306 and a standard one and a 509 rod? I just want to test it. I tested that on a small block Chevy and didn't see any power difference, but I want to try it on a different motor, and that gives me a pretty good, that's, from a 509 to a 540 is a pretty good rod length change, especially relative to the stroke. Yeah, after the viewers start coming down, then it's easier to get the like ratio. Centrifugal versus a turbo, who will win in a race? The turbo will usually win, but it depends on what they're both running for boost. You can maybe turn the boost way up on a centrifugal, and then if the boost is down on a turbo, then the race will be a better race. Okay, what are you doing?
We're bringing my car in because Tripoli not going to make it.
Okay, you're bringing it inside?
Yeah.
Okay. All right, guys, it's been an hour and 22 minutes. They need to bring another car in. This is a good time for me to sign off. Thanks, everybody, for showing up. Right now I'm working on the Dodge 360. I'm going to be taking a bunch of the accessories and everything off it, hopefully getting it up on the dyno tonight so I can run it and see if it's a runner. Thanks for showing up, guys. I will see you all tomorrow.